Greetings, Math 3 students. Mr. Eicher here with a video to talk about answers and solutions to the worksheet 7.1 to 7.3. So let's jump right in. Question number 1. Multiplying two rational expressions. The numerators and denominators have trinomials, so the best approach to take would be to factor those puppies. You cannot just divide these out. Oh no, how often I've seen that, and that is a no-no. You need to factor first, so let's do this product here. With my factoring skills, I know that you get an x minus 4 times an x plus 2. And then we get in the denominator an x plus 4 and an x minus 3. And this one over here we get an x plus 5, x minus 3. And then this puppy we get x plus 5, x plus 2. All that I'm doing, if you're amazed at my factoring abilities, all that I'm doing, for instance, is saying what are factors of 10, what multiplies to 10, that adds to 7. A little plus in there. And that would be 5 times 2. This is the shortcut type. Since all of these have a leading coefficient of 1, you can take these immediately into the factorization, the 5 and the 2. Once we have these trinomials factored, we're looking for common factors that we can divide out. So binomials that are identical, this binomial and this binomial are identical. We can divide vertically like that. We can also divide across the diagonal, like this x minus 3 and this x minus 3. And we also have a x plus 2 and an x plus 2. So it looks like after the dust settles, we just have these two factors. So we get an x minus 4 over an x plus 4. Now some students will be tempted, I mentioned this earlier, but some students might be tempted to try to divide out this x with this x. Well, let's see why that doesn't work. Let's say x is 10. So that would be 10 minus 4 over 10 plus 4. This would be 10 minus 4 is 6, 10 plus 4 is 14. If you think it's okay to go like this, well, I'll just cancel these x's. That would be equivalent to canceling these 10s, which would simplify, I guess, to negative 4 over 4. Well, these aren't equivalent, so we did something wrong. The wrong maneuver we did was to try to divide these when they're not factors. They're being parts of sums and differences. So since they're not factors, you can't divide them out. They're not being multiplied to negative 4 and plus 4. They're being added and subtracted to those. So our final answer is x minus 4. No, don't do this. Our final answer is x minus 4, x plus 4. Number 2, we have rational expressions with monomials. So we can divide out common factors. We have, maybe I'll do it this way just for explanation's sake. We have negative 16 xy times 15 z times z times z. In the denominator we have 27z times 8 times x times x. In the numerator we have x here and we have x here. We can divide those x's out, so those are gone. We also have 1z here and 1z here. We could divide those z's out. 16 divided by 8, we can divide 8 out of both, so that one's gone, and this becomes a negative 2. And then 15, this 15 and this 27 have a common factor of 3, so dividing both by 3 we get a 5 and we get a 9. So let me see what I have left. I have a negative 2y z squared in the numerator, and I have a 9x in the denominator. I don't see any more y's or x or z factors, and 2 and 9 don't have any common factors. So this looks like it is our final answer. Or is it? Looks like I might have missed, this has happens sometimes, I missed a factor of 5 at the top. So it looks like I actually have negative 10 yz squared over 9x. How's that for a final answer? Let's look at number 3. The first thing, the most important thing to notice is the operation we're being asked to do, which is this division. So we should rewrite x plus y, the fraction on the left, as a times the reciprocal multiplied by the reciprocal of this. So these are going to flip, so we get 3x squared. Now this one, x squared minus y squared, is a difference of two binomials, so we can factor that, if I could do that while I'm here. X minus y and an x plus y. And then we can look for common factors. This x plus y and this x plus y are identical binomials, so they can divide out. And we have a factor of x here, and we have two factors of x here. So this is basically a x times x right here. So one of those are going to divide out with that x. And now it's kind of messy, so I'm just going to rewrite this. Left in the numerator, I have a 3x, because this x squared became that single x. And then we have a 15x minus y. So I see that the 3 and the 15 have a common factor of 3. So divide by 3. And we have this answer. And you should not try to divide this x with this x. They're not common factors, so we should leave those alone. So that would be our final answer. Number 4, we have a complex fraction. We have a fraction divided by another fraction. I remember when I was in high school, I didn't know what fraction was with what fraction. But that blue line is the demarcation between the top fraction and the bottom fraction. So we can rewrite this. Maybe let's try to factor first. If we can factor this top of the top, we would get a x plus 6 and an x minus 3. And if we could factor this guy, that would be a x plus 6 and an x plus 1. Okay, so now let's rewrite. The top fraction is x plus 6 times x minus 3 over x plus 4. And we're dividing by this. So if we want to change it to multiplication, we'll flip that fraction to be x plus 4. This x plus 4 is in the top now. And then this factorization we did is going to be down here. X plus 6 times x plus 1. And then we can divide common factors. We have an x plus 6 and an x plus 6, so those are divided out. We have an x plus 4 and an x plus 4, those are divided out. And we're left with an answer of x minus 3 over x plus 1. Number 5. Again, be careful of the operation. We have an addition problem. So you got to kind of change gears. With an addition problem, we need to make sure both denominators are exactly the same before we add, so we need a lowest common denominator, which is also a lowest common multiple. Same idea. So one way that I like to think of it is this first fraction, for instance, has an a, and this denominator doesn't have an a in the denominator. So we're going to need to multiply on this fraction. We're going to have to multiply top and bottom by an a. so that the second fraction has an a, just like the first fraction has an a. And then this fraction right here has one b, but then this one has two b's. So to be fair, this fraction on the left needs another b factor. So to put it there, we have to put a b in the top and the bottom. And then let's see. This fraction has a 4, which is 2 times 2. And this fraction has a 6, which is 2 times 3. So the fraction on the left needs a 3 to match this 3. And then this fraction on the right needs a 2 so it can match that second 2. So notice now we have all the same numbers and we have all the same values. We just have to remember that since I multiplied this one by 3, we need a 3 multiplied by 3 up at the top. And then since we multiplied this one by this 2, we need to multiply by a factor of 2 up at the top. So we would have one common denominator of 2 times 3 times 2, which is 12, a single a, and then a b squared. That would be the lowest common denominator, also known as the lowest common multiple. In the numerator, we have 3 times 9 times b, which is 27b, and we have 5 times a times 2, which is plus 10a squared. And these terms in the numerator, 27b and 10a squared, those are not like terms. So it looks like this is our final answer, adding those fractions. Number 6. Again, what operation are we asked to do? We're asked to subtract, so we need the lowest common denominator, LCD. We need to factor first, so let's factor these denominators and see what factors we have so we can match the factors. Factoring a greatest common factor, a GCF, out of these terms would be take a 4 out, and we have an x minus 2. And then this one is a difference of 2 squares, so that would be an x plus 2 and an x minus 2. Okay, so let's match the factors. This one on the left has a 4, so we need to multiply this one by a 4 in the top and the bottom. And then this one has a x plus 2, so this one needs an x plus 2, try to fit that in there, and the top and the bottom, x plus 2. And then they both have an x minus 2, so we're good to go on the x minus 2s. They're already identical, so we don't need another one of those. So let's organize this. We have, in our denominator, we have 4x minus 2 times x plus 2. And in the numerator, we have 3 times x plus 2. So if I distribute, that would be 3x plus 6 minus 4x. So that's a minus 4 times x is minus 4x. And then minus 4 times a minus 1 is a plus 4. Be careful to distribute the negative. And then I have like terms. This 3x and 4x, I can subtract those. The 6 and the 4, I can add those. So it looks like our final answer would be negative x plus 10 over 4x minus 2 times x plus 2. And that would be our final answer. Alrighty, dighty, let's look at number 7. Number 7, again, we're subtracting. We have trinomials, so we need to factor those. So let's go like this. We have a 2 and a 6. Factoring this first trinomial, we have x minus 5 and x plus 2. That's an x. That's an x. Again, those are factors of negative 10 that add to negative 3. And it's one of the shortcut because we have a 1 out in front. Next we have an x minus 5 and an x plus 3. We have a negative 3. There we go. So let's see how we can match. Again, we need a lowest common denominator, lowest common multiple. This one right here has x plus 2, so we need to multiply this one by x plus 2 in the top and the bottom. And this one has an x minus 3, so we need to multiply this by x minus 3 in the top and the bottom. And they both already have x minus 5, so we don't need any more. They're already identical in that way. So our lowest common denominator then is x minus 5, x plus 2, and x minus 3. Those are the common factors. The numerator would be 2 times x, 2 times negative 3, so that's 2x minus 6. And then we have a negative 6 times x, negative 6x, and we have a negative 6 times positive 2, negative 12. And then we add like terms. We have a 2x and a 6x, negative 6x. So that would be equivalent to, I'm going to need some space over here, x minus 5, x plus 2, x minus 3, our common denominator. And we have a negative 4x, and we have a negative 18. You could leave your answer like that. You might see a negative 4, a negative 2 factored out, which would give a 2x minus 9, plus 9, for the numerator. But I'm okay if you leave it like this as your final answer. Alright, we have another complex fraction. This fraction bar separates the top fractions from the bottom fractions. And let's find common denominators for both. Let's see, how much space do I need here? So let's work with the top fractions. This one is a 2x plus 3 and a 2. This one is a x plus 1 with an x. Well, I notice that to find a common denominator, we're going to have to multiply this first one by the x plus 1. That's right here in the top and bottom, x plus 1. And then this one on the right, since this one has a 2x plus 3, we'll need to multiply by 2x plus 3. Okay. And that is all over. Let's see if I can write this in here. This one is going to need a 2x plus 3. These are sounding kind of the same in the top and bottom. And then this one is going to need an x plus 1 in the top and bottom. So let's see if I can write that in one step. We would have the x plus 1 that was there times the 2x plus 3. And we have a 2x that was there to begin with. And we're multiplying by the 2x plus 3. And then plus 5 times x plus 1 over the 2x plus 3 times x plus 1. Alright, so the numerator and denominator are going to have the exact same. Notice all of these. This one, this one, this one, and this one. They're all the exact same denominator. So when we combine like terms, when we subtract the fractions in the top and bottom, we're going to get the exact same denominator. So it's almost like a situation like where you have like something like this, 3/7 divided by, say, 4/7. Well, that would be 3/7 times the reciprocal, and notice that the those denominators divide out. So if these are exactly the same, they divide out and they give you 3/4. That's the exact same idea, that property right there. That's the exact same idea that's going to happen here. So really, these denominators are going to divide out, and you're just left with those like terms in the numerators of both fractions. So we would have, I get rid of a little bit of this right here. We would have 2x plus 2 minus x times 2x is minus 2x squared, minus x times 3 is minus 3x. And then we have 2x times 2x is 4x squared, and 2x times 3 is plus 6x, 5x, and a 5. And can I fit it onto the page? We would have a final answer of, adding like terms, negative 2x squared minus x plus 2, 4x squared plus 11x plus 5. Bravo, kudos to you if you followed all of that and were persistent enough to work through all those situations that we came across. So that was number 8. Let's move on. Next we have some factoring, but we have some trinomials with a leading coefficient that isn't 1. So they will be factorable. You don't have to complete the square or use quadratic formula. It'll just take a little bit more thought about how to factor them. So we'll put the 3 up here and the 4x up here. So let's see, factors, how would we factor that? See if I can guess what the factors are. So 8 times 3, that's going to be 24. That's going to be too big to get to the 2. So let's try 3x times x. Let's try 4 times 2 is 8. Let's try the 4 right here and the 2 right here. And we need a positive 2, so let's put a positive 2 here and a negative. And then multiply those and see if that works. So that would be 3x times x is 3x squared, check. 3x times 2 is 6x, minus 4x is 2x, check. And then negative 4 times 2 is negative 8, check. So I factored it correctly. Just doing FOIL, or the distributive property, twice to check my factorization. This one, we could actually factor a 2 out first. So that would make it x squared plus 3x plus 2. And then it's pretty easy to factor, actually. So take a 2 out. We have an x plus 2 and an x plus 1. Okay, now we can proceed with seeing what kind of factors we need. This one has a 2. This one doesn't have a factor of 2, so multiply top and bottom by 2. This one has an x plus 1. This one doesn't, so we need an x plus 1 over here, top and bottom. And then this one has a 3x minus 4. This one needs that, so 3x minus 4. 3x minus 4. There we go. I think we are identical now. So our lowest common denominator is a rather lengthy 2, 3x minus 4, x plus 2, and an x plus 1. The numerator, we would have 6 and then distributed, 6x plus 6. And then a 4x times 3x is plus 12x squared, and then a 4x times 4 is negative 16x. Adding like terms in the numerator, we would have 12x squared minus 12x plus 6 all over that common denominator. Just write that over there. Lowest common denominator, which is all of this. Lowest common denominator. I'm kind of interested. I noticed that we have a 12, 12, 6, so I'd like to take a 6 out and see what happens. We'd have a 2x squared minus 2x plus 1 if we took that greatest common factor out. And I don't think that's factorable, that trinomial. So our answer would be this, where this lowest common denominator is this right here. And that was number 9. Number 10, in the numerator, we need to have a lowest common denominator. So x minus 1 there, and then plus 3x minus 4. So this one needs x minus 4 in the top and bottom, x minus 4. And this one needs an x minus 1 in the top and bottom. I don't know about you, but kind of like color coding like this. On the denominator we got a 6, and we need a factor. That would be a x minus 4 and an x minus 1. And very conveniently, like we had, and I think it was maybe number 8 above, we have identical. All of these are identical denominators. So they're all going to divide out and cancel, and we'll be left with 2x minus 8, distributing the 2, plus 3x minus 3 all over 6. Adding like terms, we'd get 5x minus 11 over 6. That wasn't so bad now, was it? My apologies. It looks like on number 9 I made a mistake. I think I had that step right, but I think I said that was a 12. I'm not sure if I had written a 4 here, but negative 16 plus 6 should have been a negative 10, not a negative 12 like I had it. And then from this step to this step, since 12, 10, and 6 are all divisible by 2, you can factor a 2 out and then divide the 2 with this 2. On to some graphing practice. Graph the function 1 over x plus 2 plus 1. To identify the vertical asymptote, the vertical asymptote is when this denominator, for what x would this denominator equal 0? So x plus 2 equals 0. At negative 2, we would have a vertical asymptote. Now typically a 1 over x function has a horizontal asymptote at the axis, but since you have this shift up 1, you have a horizontal asymptote at y equals 1, which we can graph right here, y equals 1. And we have a 1 right here, so we don't have a constant that we're multiplying to 1, so we have a point here and here. And from there we're thinking of this type of graph where this point is the origin, this point right here. So we go right 1, up 1. If you plug a 1 in here, you would get a 1. If we plug a 2 into there, so right 2 from that little square, right 2 up a half, that would be that point. If we went if we plugged a half into here for x, that would be 1 over a half, which is 2. So we go from the box right a half up 2. So we get this kind of shape, like that. And then it's a reflection on the other side. So we have this point, we'd have this point here, and we'd have this point here. And this would be the other side, the other branch of our reciprocal function. So we have a vertical asymptote at x equals -2. We have a horizontal asymptote at y equals 1. The domain is all reals, but x cannot equal -2. And the range is all reals, but y cannot equal 1. And that's number 11. Let's look at the next one. Again, the vertical asymptote is when this denominator would equal 0. It's going to be a break in the graph. It's not continuous. So that would be at x equals 3. Vertical asymptote here. The horizontal asymptote typically is at y equals 0. However, you have this shift right here that it's shifting down 1. So your horizontal asymptote would be at y equals -1. So -1 on the y. You can see that this little square is at the point +3, -1. So from that shift, we could see you're going to go right 3 and then down 1 for that little box right here. And when we graph, we have to take into consideration this -2. So if you're trying to think of points to graph, you're going to be thinking of this function, -2 over x. If we plug in 1, that would be going right 1. If we plug in a 1 here, that would be a -2. So we go right 1, down 2. That would be right here. If we plug in a 2, that would be right 2 from the little square. Right 2 from the square, down 1. And if we plugged in a 1/2 in for x, that would be right a half from the little blue box, and then down 4. Looks like we might have just made it. And we're going to have a reflection on the other side. We're going to be, instead of right 1, down 2, we're going to go left 1, up 2. And we're going to go, instead of right 2, down 1, left 2, up 1. And then that point down there was a half up 4. 1, 2, 3, 4. So it looks like our graph would look like this. It's going to get close to the asymptote, curve up like that, and then curve down like that. Notice this negative made a reflection. Typically it looks like this, but we've reflected, so now it looks like this for our answer. That was number 12. Excuse me, the domain and range of number 12. Let's see if I could do it without a graph. All reals except x can't equal 3, and then the range is all reals except y cannot equal -1. There we go. Okay, on to number 13. Number 13, you should have used Desmos.com to graph, so let's look at Desmos. Here is the function that I typed into Desmos. You'll notice that we have a vertical asymptote at -1. I hope that's not a surprise, because when is this function undefined? It's undefined when x is -1. It also has a vertical asymptote at 4, x equals 4, and I hope that's not a surprise, since this function is undefined when x equals 4. We also have a horizontal asymptote at y equals 0 is HA, horizontal asymptote. There was no adding or subtracting out here, so there was no vertical shift, so it should be where we would expect it to be. The domain would be all reals except those two numbers, would not be in the domain, and the range would be all reals except 0. So that's the function for number 13, I think it was. And lastly, number 14. Let's factor first. We can factor the denominator as x plus 4 over times x minus 3. And we add a minus 3 in the numerator. Really important to realize that these can divide out. And anytime you have a factor like this divide out, this tells you the location of a point of discontinuity. The point of discontinuity would be when x minus 3 equals 0. So at x equals 3, there's a point of discontinuity. That's the hole in the graph, is at 3 comma somewhere. To find the y-coordinate, we would divide these out, and we're left with the simplified version, 1 over x plus 4. We would put that 3 into that, so we'd have 1 over 3 plus 4, which would give us the coordinate 3 comma 1/7. Hope you can see that 1 right there. So we can graph that point. We'll graph that in a second. This factor that did not divide out with anything, that tells us the location of a vertical asymptote at x equals -4. So we have a vertical asymptote here. We have a point of discontinuity at 3 comma 1/7, which is a little off the graph. It would be, I guess, over here somewhere off the graph. Horizontal asymptote will be at y equals 0. And this graph should look like a typical graph, like from the little box here. We go right 1, up 1, so just thinking of plugging numbers into this, and that tells you how much it shifts from the little blue box. And then right 2, up a half, right a half, up 2. So we would have a graph that looks like this. And it continues to here, and then there's a hole in the graph, and then it keeps going. And then likewise, you can't really see it very well, but you would kind of go the same way down there. The domain would be careful here, the domain, maybe I'll write it right up here. The domain would be all reals except x cannot equal -4 or 3, the location of the hole in the graph. The range, the y's cannot equal 0 or that 1/7 that we got when we plugged 3 into the simplified version of the function. I believe that is it with this homework assignment. Hope you found that helpful. Until next time.